Hi, and welcome to another Hopper languages video. Hopper is a modern semicolon and curly brace language similar to Java or C#, but without classes and designed to run on small devices like microcontrollers and 8-bit CPUs. I designed this language to be familiar to people who are used to C, but I also decided that I should do some things to improve on C. So, for example, that is initialized to 0 by default. Everything is initialized to a 0 value. So if I make a Boolean, it's initialized to false, right? Now, in C, you could do things like if a like that, and yes, the linters pick it up nowadays. But you can see I've deliberately programmed an error here. I've assigned 0 to A instead of checking it against 0. So if I compile that in Hopper, if you look at the bottom of the screen, error at A, Boolean expression expected was uint, right? So it didn't like that, because it was expecting a Boolean expression. It actually stopped after the A and gave us that error message. That's the uint part. Didn't even get beyond that. So what we're touching on here is the difference between an expression and a statement. Hopper gets a lot of its flavor from Pascal as well. And in Pascal, you'd have a definition like that to let's do something we can actually implement. Floats square value, and then return value. So in Pascal, that would be a function, right? And in Pascal, this would be a procedure. So this would be in Pascal, this would be called a procedure. And this would be called a function. C does not distinguish between them. And I believe even C# calls them both methods, only the one has a void return value. So they have this concept of void. Hopper doesn't have void. Like Pascal, it just has procedures and functions. Right. So let's give ourselves a string here. And so there's a couple of things that are going to be strange about this that are not like C. So firstly, you can't put a statement where you want to have an expression. So another way of putting it is that procedures are statements, and functions, because they return a value, are a type of expression. And a procedure is a type of statement. And the difference is statements don't return a value and expressions do return a value. So if I try and compile that, it should fail. Actually, so that prompting me to save on compiling, I can click this save on build and it won't prompt me again. Boolean expression expected was void. So it knows that's void. It knows this is a statement. I can't put it there. And it specifically wants a Boolean expression too. So I can't put a statement where it's expecting an expression. And if I try and put my function call here, so like that, it's going to do the same thing again. It's going to say Boolean expression was expected was float. So I could say that is greater than 0. Now it's a Boolean expression. And we're quite successful with that, right? So that's the one thing that's it solves. You have to use an expression where an expression it makes sense, and it cuts out a whole series of programming errors because your actual intent or the intent of the person who wrote the library is respected better. So let's do this. If I wanted to convert that string to an integer, in C I could go A to I and stir, and it would convert like that. But if there was an error in here, it would actually still give me the value 100 right now. If it was just that, it would give me the value 0. So I can't tell from that whether the return value is actually 0 or whether it's the error value 0. So in Hopper, to detect error values, you just have a second return value. Now, in C#, you could do a parse like that. And I think you'd have to go un parse like that to use the correct parse or whatever. It might do it. So it would parse that string into a uint. And the problem with this approach is, again, how does it deal with the errors? So if you passed in a negative 100 here, but it's an unsigned int, how's it going to fail? And the answer in C# is that it throws exceptions. Well, Hopper doesn't have exceptions. But luckily, C# had another way of doing it. And that was to pass out the value, the result, as a reference. And by doing that, it would return a Boolean value success, like that, right? So that's what works in Hopper. So this should fail right now because it's negative. Let's see what happens. Uint parse not defined. Oh, I haven't included uint. Oh, sorry. In the one that try parse is the one that does the two values. So you've got two values being returned from a method, from a function in this case. The one is the return value of the type, and the other one is success or failure. So let's launch. We've got to launch onto my. I'm hooked up to a microcontroller, a Raspberry Pi Pico, but I have to generate IX to upload if I want to run this on the microcontroller, and I want to because I want to see it in the debugger. So there we are. Bottom of the screen, it's uploaded to my microcontroller. This area on the right here is the serial connection to my microcontroller. As I step now, I'm executing the code on the microcontroller. So it initializes A to 0, like I said. Flag is initialized to false. String is going to be initialized to -100. And now it's going to try this try parse. And the result is false. It failed because it was negative. Right? So if I make it positive, and I can do this, so if it succeeds, and I can convert it back to a string just to see it. Say success, yeah. Do that, right? And launch it into the microcontroller F5. We see in the top right here in the serial port, it printed 100. This is code that's running in the debugger, but the code's running on the microcontroller. That's how Hopper works. Okay, back to the editor. All the shortcut keys I'm using are on the menus. They're on the right here. You can find them quite easily. Okay, so this kind of code to return values, etc., etc., it can get a bit tedious if you know for a fact that it's always going to be true. Like if you've got some hard-coded values and you never want to check. So you end up writing boilerplate code that looks sort of like that. Okay, there we go. I've solved the problem. So I get my return value and I do nothing with it. And C# had the same problem because they also they insist that you consume the value of an expression. You can't just throw it away like you can in C. So in C, you could just call, you could just do this. And it would compile. In Hopper, it won't compile. In C# it won't compile. It says here on the bottom right, return value must be consumed, right? So if I don't want to consume the return value, there's a short sort of syntax shortcut to throw it away. And I've borrowed that from C# version 7. They introduced this discard symbol. I know it exists in other languages as well. So now it's going to just discard the value, and I can do the same for this. Get rid of my boilerplate. So this has the advantage of still showing that you did it on purpose, so the intent is preserved. You didn't by mistake make a mistake, coding error, but you've got a little less boilerplate. So let's launch that in the debugger. So as I parse this to 100, I get my 100 on the right chain A, and it just throws away the return value. And of course, this is going to do very little. I'll step into it just to demonstrate the debugger stepping into my square, and it throws away the result. Very useful feature. Anyway, that's what discard is. It allows us to still maintain the strict distinction between statements and expressions, but allows us to very easily, with less boilerplate, discard the return value of a function. And yeah, you still can't put a statement where it's expecting a function, like in an expression, like an if condition. Anyway, that's what discard is. Thank you for watching. I look forward to your feedback in the comments. I'll end this video on a playlist to other Hopper languages videos, and also a link to the quick start getting started with Hopper on Windows, getting the IDE up and running on Windows and connected to your microcontroller in less than 5 minutes.